Guys, that's Rise here, and today we'll be talking about different types of products, right, in vectors. So if you haven't watched the previous video on introduction to vectors, please go ahead and watch it. There we talked about what are vectors, right? We talked about addition of vectors, we talked about scaling of vectors, and then we talked about subtraction of vectors, and lastly we talked about some properties involving addition of vectors and as well as scaling. So today we'll be talking about multiplying. So we can add, we can subtract. Can we multiply vectors together? And the answer to that is actually there's two ways of multiplying. There's two definitions of products. So yeah, so why are there two definitions and what do they mean? So once again, we'll be going through the geometrical and arithmetic picture of vector multiplication. So the first type product, right, is called the dot product, and the second type is actually called the cross product. So let's talk about the dot product first. So let's write dot and cross over here. Yeah. So the first important thing to note is that the dot product takes in two vectors, denoted with a dot like that, and it spits out a real number. So it spits out a real number. Okay, and this contrasts with the cross product because the cross product takes in two vectors, right, and we denote it with a cross like this. Takes in two vectors and it spits out another vector. So it spits out another vector. So fundamentally, the dot and cross product are different because both of them take in two vectors, but they perform different computations, and one of them spits out a real number and the other one spits out a vector. So yeah, so for the dot product, let's talk about numerically first. Numerically, how do you calculate the dot product? So the numerical way to calculate the dot product, let's say we are given A, B, C dot D, E, F. The dot product between these two vectors is AD plus BE plus CF. So let's go through an example. For example, let's say we have the vector A equals to 1, 2, 3, and the vector B equals to, let's say the vector A equals to 2, 3, 1 in alignment with our previous example, and let's say the vector B equals to 1, 2, 3, then A dot B equals to 2 times 1 plus 3 times 2 plus 1 times 3. Okay, and this is equals to 2 plus 6 plus 3, and that is equals to 11. So the dot product gives you, it takes in two vectors and it gives out a real number. So you might be wondering, why this definition of dot product? Can't I do something wonky like AE plus BD plus CF? Wouldn't that also be kind of a definition? And the answer is, sure, you could define your own dot product, but is it useful in computing something, right? Is it going to be computing something useful? And so what is this dot product computing? This dot product is actually computing how similar two vectors are. So the geometrical picture of the dot product is that, right, if you have two vectors A and B, you dot them together, then it's equals to the length of A times the length of B times the cosine of the angle between them. So this, I did not talk about this thing, right? This absolute sign is not the absolute, is the magnitude. So this is the magnitude slash length of the vector, right? And this is the angle between them. Okay, so I did not talk about magnitude the previous time, but I believe that you have probably come across the Pythagoras theorem at some point in time in your secondary school. So yeah, so let's quickly talk about length because I forgot to talk about it in the previous video, but it shouldn't be too difficult. So if you have a vector, right, if you have a vector with components x, y, z, the length of A is simply the square root of x squared plus y squared plus z squared. So that's how you compute the length of vector. So let's just go through a quick example. So let's say a equals to 2, 3, 1. Then the magnitude of a is equals to square root of 2 squared plus 3 squared plus 1 squared equals to square root of 4 plus 9 plus 1 equals to square root of 14. Okay, so the length is always positive. Yeah, and sometimes you might see people write it as magnitude of a squared equals to x squared plus y squared plus z squared. It's just squaring both sides of this. Both are valid definitions. So yeah, back to here, the geometrical picture of a dot product, right, is the length of them times the cosine of the angle between them. So what does that show? So let's say we have vectors a and b. Okay, so let's split into a few cases. So let's say case 1, a dot b is greater than 0. So what would that imply? So pictorially, let's say a and b is like that, then the angle between them is less than 90 degrees. So theta is less than 90 degrees. And hence cosine theta is going to be greater than 0. And that will make sense because if a dot b is positive, then that means that magnitude of a, magnitude of b cosine theta is greater than 0, which implies that since magnitude of a and magnitude of b, they are both lengths, so they are both positive, that means that cosine theta is greater than 0. And that means that theta, which is between 0 and 180, and that means theta is less than 90 degrees. So that means that the angle between them, so if the dot product of two vectors is greater than 0, is positive, right, then the angle between them is acute. So the dot product gives us some information about the angle between vectors. So what about the second case? Second case, if a dot b is 0, then that would mean that length of a, length of b, cosine theta equals to 0, and provided that none of them are 0 lengths, then that would mean that cosine theta equals to 0. And what does that look like? Then that will look like theta equals to 90 degrees. So that means that a and b are perpendicular. So a and b are perpendicular to each other. And for the case where the length of a or length of b is 0, then it's just one of them is 0, so it's just a point like that, and hence the dot product is 0 as well. Okay, so that's the second case. So if the dot product is 0, then we know that the two vectors are perpendicular. And last case, if the dot product is negative, then that means that that means that the length of a times length of b cosine theta is less than 0. That means that cosine theta is less than 0. And if you look at the graph of cosine, right, so this is cosine theta, and this is theta, and this is from 180 degrees, and this is 0 degrees. Then we know that it's between 90 and 180. And that would mean that the angle between the two vectors are obtuse. So it looks something like that. Oh, sorry, it's supposed to be underneath. The tilde is supposed to be underneath. So then, if the dot product between two vectors are negative, is negative, right? Then the angle between the two vectors is obtuse. So you know that they're pointing in, yeah. So one question that you may ask is, what about other ranges of angles? Can we have angle equals to 270? And the answer is that because angle equals to 270, like that, right, it just corresponds to 90 degrees in another direction. So the angle between vectors is always going to be between 0 and 180, because between 0 and 180, right, it goes one full round, and as soon as it starts going to the other side, right? Instead of choosing this direction to count the angle in, we can choose this direction. So by definition, the angle between vectors is always between 0 and 180. So we have seen over here that the the dot product gives us information about the angle between vectors, and as a result, is a useful quantity to compute. And you see later that the dot product also gives us convenient ways to calculate distances. Yeah, and I'll show you what I mean by that. So another way to think about it is, besides just giving us the angle, right, the dot product also gives us information about how similar the direction of two vectors are. If you see that they have some similarity in direction, so for example, these two vectors, they have some similarity in direction, in the sense that if you project one of them down to the other, right, then the dot product will be, then the angle between them is acute, and the dot product is going to be positive. If they are perpendicular, then it's going to be, the dot product is going to be 0. And lastly, if they are kind of pointing in opposite directions, in some sense, that you project one of them down, then you're going to get pointing in opposite directions. You're going to get that the vectors are pointing in opposite directions, then the dot product is going to be negative. So yeah, okay. So another way, yeah, so you see that it's the idea of projection down, right? And we'll be talking about that in the next video. Yeah, so let's talk about that in the next video. Thank you. See you there.